This video is entitled Lists and Tuples and goes along with Chapter 4 of An Introduction to STEM Programming with Python. I'm Dr. James Reneau, and I'll be taking you through this introduction. In this video, we will discuss how to define lists and tuples and what they are, creating lists or tuples with values, creating a list with braces and the list object, accessing values and slices from a list and from a tuple using the indexing operator, like we did with strings, changing values in a list, and deleting items from a list. So what is a tuple? Well, let's talk about what a tuple and a list are. They're a data type within Python that lets us store multiple items together in a single variable or into a single structure. It allows us to deal with them as a single chunk, even though it's lots of different values. A tuple is a read-only collection of values. So once you create a tuple in your program, you can't change it. But a tuple is pretty handy to have sometimes. So you define a tuple inside of parentheses, and you can see here I define the tuple T containing the numbers 1, 2, 3, 4, and 5, and you place a comma between the values. Sometimes you may want to create a tuple with only one value, and to keep Python from getting confused of are those parentheses just around an item, meaning to do that first, or are those parentheses around a tuple, you have to put that extra comma at the end when you're defining a tuple of a single value. But a tuple is a list of values that is read-only that you can use throughout your program. So now that we've talked about a tuple, let's talk about what is a list. A list is another built-in data type that allows you to create a group of values. Now, a list is mutable. In other words, you can change it, modify it, add things to it, sort it, do things, and we'll talk about those in this video and the next video. Lists are created using the square bracket notation, the keys kind of above the quotation mark on a standard US keyboard. And you can see that I've created a couple of lists above. The list of animals that contains the string cat, the string dog, and the string snake. And then a list M that contains the numbers 1, 2, 3, and 4. You can use the if you ever needed to create an empty list, a list with 0 items in it, you can use just a set of empty square braces, as you see when I create the empty list X, or you can use the list function that's built into Python to create an empty list. When you're creating a list, be sure to separate each of the values with a comma, and they don't need to all be the same type. You can create a list with a mix of strings and numbers. You can even create a list containing other lists, a list of sublists. A list is a really powerful thing, and you'll be doing it a lot or using them a lot as you program in Python. So here's a little program where I create 4 lists. The first lists are called list 1, list 2, and list 3, and the first 2 contain nothing. They're empty lists. The next is a list of the numbers 1 through 6, and the next is a list of common pets people have, cats, dogs, fishes, and snakes. So on lines 6 through 9, you can see that I print each of the lists, which is what we see up above. And then on line 11, notice that I create a list that contains the 4 lists. So I have one list called the list of lists that prints out above that contains all 4 lists as sublists. So there's some creation of empty lists, some regular lists, and then a crazy list of lists. And we can also use the indexing operator that we saw when we were manipulating strings in a previous week's work to pull individual items from a list or from a tuple. Remember that the index starts with 0, so the first item is 0, and the last item would be the length of the list minus 1. So here we have a simple little program using the same 5 lists that we created in the previous example to show how to use the indexing operator to extract items from a list. On line 7, you can see that we extract the item at position 1, the second item, from the list of pets, and you can see above it printed dog. On line 8, you can see that we extract the third item, or the item at index 2, from the list of lists, which is the list of numbers, and it printed that list from the other list. And you can see that I'm using the negative position, where -1 extracts the last item in the list. So -2 extracts the next to last item in the list to extract the number 5 from the list 3. So you can see the results of that little program and using the indexing operator to get a single value from a list. You can also use the indexing operator with 2 values, a start and an end, like in strings, to extract something we call a slice from a list. By using the indexing operator to extract a start colon end, we don't get individual items. What we get is a sublist or a sliced list, a list sliced out of the other list. It works like a substring, but it always returns a list or a tuple. So if you're slicing a list, it returns a list. If you're slicing a tuple, it returns a tuple. It extracts the items from the index of start to 1 less than the end, like it did in a substring. Start may be omitted. So you could say list square bracket colon number, and it would assume that we're starting at position 0. The end may also be omitted, so you could say list bracket start colon nothing close bracket, and that extracts from the beginning all the way to the end, however many items there are in a list. So this gives us a sublist or a slice or a subtuple or a slice of a tuple. We have a new list that we're playing with called the list people, and it contains a whole bunch of people's names. You can see that we print people, and there it is. You can see that we create a slice starting at position 1, index 1 ending at 3, which would give us index 1 and index 2 in a sublist. So you can see the sublist of Bob and Charlie, or the slice. We then say, well, slice the first 4 from the list, and you can see that it sliced Amy, Bob, Charlie. We did that on line 9. You can see that on line 12, we start at position 5, start at index 5, and move to the end, and you see that we got Frankie and George. And you can also see that I said start at position -2 and give me to the end, which would give me the last 2 items. If you wanted the last 5 items of a list, you could say -5 colon, like we did on line 15. We can also use the indexing operator in a special way to reassign or change items in a list. We can't do that with tuples, and we cannot do that with strings, but we can do that with a list. And I'll show you that on the next slide. So here we have the list of the same people in the list of people on line 1 that we had in the previous example. We print it out, which is what I do on line 3. Notice on line 6, though, I've decided that I'm going to change the person at index 1 from whatever it was to Betty. And you can see that above, Bob is now Betty on the list. So you can use the indexing operator to replace an individual item. You can also use the indexing operator to replace a slice of a list. So you can see that here I change from index 3 to index 5 non-inclusive, so it would get rid of 3 and 4, or Danielle and Evan, and replace it with Danny, Sue, and Edna. So you can see that Danielle and Evan are now not in the list, but Danny, Sue, and Edna are. Really powerful to be able to modify individual items in a list and modify slices in a list by inserting or by replacing it with another slice. With lists, you may also use the del statement to delete an item by its index. So you say del space the variable containing the list, indexing operator with an index, a number, and it will delete that item from the list and collapse the rest of the list back into the, and collapse the rest of the list. There we go. So next slide. Here's our list of people again, and you can see on line 6 that I delete the person at index 1, which would be Bob, and then you see the list when it's printed out after that delete doesn't contain that item, and all the rest of the items have moved up into the previous locations. This concludes the brief introduction into lists and tuples, and I'd like to say thank you for watching. Remember, this presentation is copyright 2020 by James Reneau Ph.D. You can contact me at jreneau@shawnee.edu. Remember also that this work is licensed under a Creative Commons Attribution, Non-Commercial, Share-alike 4.0 International License, and I'd like to again say thank you for watching.